Hi everybody. Today I'm going to do a example of using Ansys Mechanical. We're going to solve this problem right here. As I said, as I learn things on Ansys, I'm going to try to help other people out and post these types of tutorials. So this is the problem statement. And basically what we're going to do is use Ansys Mechanical to create this model. We're going to mesh it, we're going to apply loads, and we're going to make sure that our supports are constrained. And then we're going to list some outputs, and we're going to plot the deformation, and I'll show you how to animate it as well. Okay, so in the end, or actually not in the end, but the geometry or model in Ansys should look like this, is elements and the element numbers. But I'm going to go ahead and show you all that right now. This problem's in imperial units. So go ahead and open up your mechanical product launcher for Ansys. I already did this problem, so I'm just gonna start from scratch and make a second, second trial. Okay, so right from the beginning, first step, of course, is to go through preferences. For our case, we've got a structural problem. Okay, I'm gonna save it. Now we go into the preprocessor, and we're gonna choose the element type. Now this is a 3D problem, okay? And what you want to do is we can do 3D or 2D. The reason why I'm doing 3D is because there's very little difference, and I'll show you exactly what those are. And the first difference will occur when you're choosing the element type. So when you choose the element type, click Add, Add again. Now we go to Link. Okay, now if it's a 2D problem, you would choose 2D spar 1 for 2D truss problem. For 3D, I'm going to choose 3D spar 8 and click OK. Close. Now, let me maximize this. Now, the next thing we do is we're going to choose the real constants. The way this works is basically you choose the element type, which tells Ansys, what kind of members you're using, and then the real constants you will specify the cross-sectional area. So in our problem, the cross-sectional area is 3.2 inches squared, and just also make note that the modulus of elasticity is 29 e to the 6 psi. It's also very important to make sure that all of your units are the same throughout. So over here in the geometry there are feet. Make sure you convert those to inches. That's always true with this Ansys Mechanical. You can use either imperial or system international units or SI units, but you have to make sure that you're consistent and that you're using meters and in this case inches. Okay, so the cross-sectional area is 3.25 inches squared. We're going to go ahead and input that as a real constant. Click Add. Click Add again. If you had different types of elements, for instance, if you had a beam, you'd want to differentiate, but in this case we only have one type of element. And then you enter the cross-sectional area, and we don't have an initial strain, but if you did, you'd enter that there. And the next thing is to choose the material properties. For our case, we have the modulus of elasticity, so we're going to go to the material models. We're going to do structural, linear, elastic, isotropic, and EX is where you input the modulus of elasticity. If you ever see any of these abbreviations and don't know what they are, you can always click help here, and that'll open up a page that will explain in detail what you have to input. So let's go ahead and input our 29 e to the 6. We don't need to put in anything else. Set to 0, that's okay. Close this out. And now we have the element type, the real constant, and the material properties are done. Let me just show you how to list it. Go up here to list, down to properties, element types. This will list your element type. For our case, we only have one right there. Link a 3D spar or truss. Close that out. You can also list the real constants. In our case, we only have one. In some problems, you'll have different cross-sectional areas, different types of beams. So you would see different information there. All the materials we have, that is correct. 29 e to the 6 or 0.29 e to the 8. Good. And I'm going to save it. Now the next thing is we're going to start to create our model. You can do it different ways. You can create key points and then create lines and then go in and mesh it, which is the way we're going to do it. You can also create nodes and then create elements. But I think that for this case, here, let me actually make note. So for trusses, I think it's more simple to do key points. And key points essentially represent the joints in your structure. So each of these places will be a key point, and then in between the two you'll draw lines, and we'll do that right now. If you had, let's say, a beam, right, and you wanted to know the stress at a point in the middle of the beam, which is often the case, in that case you would rather, it would be better to first create the nodes and then the elements instead of first creating key points. And if that sounds confusing, don't worry, because once you start working with the program, it's pretty easy to figure out. So modeling create key points I use in active workspace, and what we're going to do now is create each of these joints. Alright? Each of these joints. And I've already done this problem, and to save time I already know the coordinates of all these joints, but really if you were doing a problem like this, you just have to set somewhere, choose an origin, and then go from there and find out your x, y, and z coordinates, and that's all that I've done, but I kind of did it ahead of time. So I know that my key point 1 is 0, 0, 0. This is your x coordinate, and it should tell me that with my cursor over it. Okay. Well, this is your x, y, z coordinates listed here. Click apply, and second key point for us is 0, 0, negative 48. Click apply, and as you start applying this, you should see them start popping up in this window here. So our third coordinate is 0, 36, negative 24. Click apply. See how that showed up? 24, 0, negative 40. So apply, fifth key point, 24, 0, negative 40. That's not right. Give me a second. Let me figure out really quickly.